Hello, everybody. Welcome to Alex Does LeetCode, where we do programming problems together on stream. Alright, so first, give me a second to adjust. Okay. Alright, I think we have it. So I've modified my setup a little bit, so the chat is now front and center, which allows me to see everybody's chat on the same screen as I am working on the problems. And this hopefully will help me respond to your messages a little bit quicker. Alright, so for today, let's see what's happening today. So today we're going to work on problem 148, sort list. And this is a very special list. This is not the normal list that we have. This is a linked list. And linked list works like this. In case you're not familiar with the linked list structure. A linked list has a series of nodes. So there's this node here. Let me just use my magic pen. There's this node here called the head node. The head node, which is what is alluded to here. Okay? And the way the linked list works is that the first node points to the next, which points to the next, and points to the next. So the head node points to the second node, which points to the third node, which points to the fourth node, and so on and so forth. Until the last node, this guy doesn't have anything he points to. And then we know we're done. So the thing that makes the linked list a little bit different from a regular list is that it's harder to extract things from the middle of a linked list. So you can see here, to get to the third item, to get to like this, let's change a different color. So to get to this item here, you had to make 2 hops from the beginning. You can't just jump to it the same way you do for a list, a regular list, or an array. Okay, so you have to. It takes a bit of time to traverse to the middle of the list, and the further down the list you go, the longer time it takes. The other thing about the linked list is that one of the advantages of linked list is that it makes it easier to break the list into 2. So if you have an array, you want to break things into 2, and then you want to rejigger things around. That's tough, right? You want to take out this node, and this guy is in the middle of a very long array. Then you have to move everybody. You have to move everybody up by 1. Whereas in a linked list, all you have to do is say, well, number 2, you're now connected to number 3. So this guy is now connected to this guy over here, and then this guy will be gone right away. So linked list is quite useful in some situations. It depends on what kind of insertion and what kind of read and write characteristics you have. Today we're not going to be talking about what the linked list is good for. Instead, we will be sorting the linked list. And the way it works is like this. We have a list node here. We're given a list in basically any order, and we want to put it into ascending order. And I assume that these are all numbers, right? Yeah. So these are all numbers. Oh, sorry, this is plus minus 10,000, and they are up to 50,000 nodes. Okay, so well, the first thing I'm thinking of is just to use a simple merge sort. The reason why I'm using merge sort versus something like a quick sort or anything like that is quick sorts don't work as well on linked lists. Actually, I'm not sure. Let me think about. Maybe they do work fairly well. Maybe they might work fairly well. Let me just describe this really quickly so people can follow my train of thought. So the quick sort does not. If you guys remember the quick sort, there's a lot of swapping nodes around, right? So for instance, you have a fulcrum, and then you have to move everything that is before the fulcrum to its left, and then you have to swap the fulcrum all the way to the end. So these swapping things around, that's not something that I don't know how quick it is to do using a linked list. Maybe it'll be quick. Maybe it's just a matter of. Oh no, that's gonna be tough because you have to go to nodes in the middle and at the end. And as we said before, linked list does a terrible job of finding, looking for nodes based on where they are. Okay, so looks like a merge sort might have the same problem, because merge sort requires us to. A merge sort will basically break the list into two, sort them, and then merge them together. What else can we do? Well, we can do some kind of insertion sort. Okay, we can do some kind of insertion sort. Let's do some kind of insertion sort, which is we start by looking at each element of the list, and then we put that into a new list, and for each successive element we find the right place to put it. So we can say 4 goes to here, okay, and then 2 has to go before 4, so it goes to here, and so on and so forth. And we sort of insert them where they go. So let's try an insertion sort first. I don't think this is the fastest way to do it, but let's see, merge sort, Actually, maybe the merge sort might work. The merge sort might work. Sorry, the quick sort might work. The quick sort might work. So if I take the first one, and we sort everything else based on whether it's the left or the right. Actually, you know what? The quick sort might just work. Let's try with quick sort. Okay. So we have a head. So the way we're going to do this is we're going to use use head as the fulcrum. So the fulcrum is the midpoint of a quicksort. And what we're gonna do is we're gonna put elements either on the left or the right side of the quicksort. Okay, either left or the right side of quicksort. I think the quicksort will work. But let's try it out. If it doesn't work, we'll scratch everything and try again. Right? Remember, the first try is free. Don't think about solving your programming problem on the first try. The first try is just test things out. See where we get. Okay. Let's call it a head value equals head dot val. Okay. Okay. Now we're going to create two new lists, before and after. Can I do this now? What's the now in Python? I forgot. Oh wow. Is it new? None. Gotcha. Equals to none. After equals to none. Okay, we'll have before and after. And what we're going to do is we're going to go through the list. We're going to say while we're going to go through the list. We're going to have before and after. We're going to go through the list. And at each point, we're going to put things either into before or after. So while, let me see how this is going to work. Okay, while iter not equals to none. So iter is the current node we're at. So let me draw. So head starts here. And then iter will be here. And iter will go on and on and on. So iter is the one that's traveling. If it's larger than head value, let's call it the mid value. I think that's the more accurate term. So it's larger than mid value. If before equals to none, before equals to iter, else. So we're gonna look at what this is. For each iter, we're gonna check if its value is larger or greater than head. This is a classic quicksort. If it's smaller than head in this case, we're going to add it to before. Since before is currently empty, we'll just do before equals to iter. Otherwise, before dot next equals to iter. Otherwise, if it's not empty, then we'll add it as the next item in before. Else, we do the same, but now for after. After equals to none. After equals iter. Okay. Okay. And then what happens next? And we're gonna repeat until iter equals to none. And once that happens, we are going to set before. Oh, wait. Okay. Okay. So so after we've added, so it's gonna look something like this. We have head, which is here, and then we have before and after. So we'll add 2 to before, and then we see 1, right? We'll add 1 to before, and 3 also goes to before because the head is 4. Right? All these numbers are before, are smaller than 4. And what we do, this step is actually it advances. So this advances iter to the next. It goes from 2 to now 1. And so this O iter dot next equals to none. This is a little bit of forward thinking on my part. Basically what I want, this is not forward thinking on my part. Okay. So basically what I wanted to do is I wanted before to end with a none, and then after to end with a none. I want both of these things to end with none. And the reason is because I'm going to sort them next. Okay? So instead of doing this, I'm going to do last before, last after. And so this is important. This is important. Let me just do this. Let me just do this right now and show you guys why we actually need to do this. Okay, so now that we've sorted these things together, we have 2, 1, 3, we have a 4, and we have add, right? Now we do stitch before, mid, and after together. So what we need to do is to say, for mid is easy, right? We just do mid dot next equals to after. But before is tricky. We can't do before dot next equals to mid, because before points to 2. Before is 2. It's not 3. We want to say 3. We want to say after 3 is mid. Mid is 4. So we want to say 3 goes to 4. So this is a little bit tricky. So what we really want to do here, is not before dot next, but the last before dot next. So we sort of have to keep track of the last before and the last after. Okay, so we're gonna stitch them together. But before, so that allows us to do this. Last before equals after, mid dot next equals to after, and then last after dot next equals to none. We want to like seal it off. We want to seal it off. Okay. So this is the idea. So this is the general idea. First, we figure out a first we figure out a fulcrum, and then we iterate over the list and put things either on the left side or the right side of the fulcrum. So either before or after. And then finally want to stitch them back together. And at the end of one iteration of this, we should get 2, 1, 3, that's before, 2, 1, 3 is before, 4, which is mid, and then after, which is nothing. Okay, cool. Okay, this works for one iteration. There are a few bugs here. If you're still, you'll realize right away that, hey, well, before mid does not always exist, right? Before can be none. Before can be none. If before is none, then head has to go to mid. After can also be none. And likewise, if after is none, then, we have to go to mid. Okay, cool. So this sort of works. So the next step is to repeat this on before and after. So I'm gonna take this out and put this as a separate function. Actually, let me think about how to do this first. So we basically have to repeat. Okay, let's just call the recursive version first. So we're gonna start by writing the recursive version. There are a number of problems with the recursive version. Okay, whenever you use recursion, you have to be very careful because there's this idea of a max recursive stack. The way recursion works is that you may not personally save a lot of data on each iteration, but the computer does. The compiler has to remember every single level of recursion. So there's this idea of a max recursion stack depth. If you exceed a certain depth in your recursion, your program will simply crash. So you don't want that. So you have to be very careful. I don't know what kind of test cases this will have, and I think that will not work well. Okay, on recursion, but let's see how it works first. What are we supposed to return, by the way? Okay, optional lists. If head equals to none, and before equals to none. Okay, let's do this first. If head dot next equals to none, return head. So if head dot next equals to none, that means there's just one node in this list and we're done. So we guarantee that either before equals to something or after equals to something. So if before equals to none, then head equals to mid. Mid dot next equals to after. And then last after equals to none. Excuse me. So I'm repeating a few things here because I like clarity. I don't mind verbosity, so I don't mind writing more code. But I like clarity. Right? So anybody reading this just sees if before equals to none, else if after equals none, else neither of them are none, do this. I could potentially merge this. Let me see. I could say like if before equals to none, do these steps, else do this head equals to before. But I feel like I will be saving a very, very small amount of code. And I can't be bothered to save that amount of code. I would rather repeat myself a few times. Okay, so return head. Let's run this and see what we got. So this should give us 4213. None type has next attribute next. Line 8. Oh, this does not bode well. This should never happen. 4213. Oh, interesting. So it does happen. Okay. Cool. So it did happen. But it's completely wrong. Oh, it works for a trivial case. So it didn't do any sorting. Why is that? Head equals to before. Oh, it does 423. Huh, interesting. Okay, you know what? Let's stick this into Python Tutor. And visualize it and see where we get. Okay. So the input is this. Oh, this is a pain. So I have to construct the input myself, which is a real pain. I have to create this list node, and I actually have to construct it myself. Ugh. Let's try debugging a little bit before we jump into that. You know what? Let's do go ahead and construct this myself. Okay. So list node. Val equals 0, next equals to none. So you can put val and a next. So val is 4. Put equals list node. Two, 1, 3, 2, list node 1, list node 3. I think this should work. Unfortunately, input is a reserved word. Okay, let's see what happens. Let's go to here. Okay. So this is our input. 4, 2, 1, 3. We have head here. Let's see what happens. Mid value equals to 4. Okay, cool. Mid equals to head. Okay, mid equals to head. And then last, all these are empty. So while iter not equals to none. So iter equals to this guy. I'm starting to really appreciate Python Tutor. Oh my god. This is really helpful. This visualization is particularly helpful for this problem. Okay. Oh, I see what's happening now. Wait, iter value is larger than mid value. First of all, this should be reversed. So after goes to here. That's correct so far. So now last after also goes there. Iter goes to here. Okay, cool. So far so good. So if iter.val, let's get a bit more real estate here. Okay, if iter.val larger than mid value, nope. This is a bug. So this should be in after. Last after dot iter, after dot next. Oh, it's not after dot next. I see. You see what the problem is? The problem is this. It's the same reason why I had last after here. Last after dot next. This is not after dot next. This is last after dot next. And this is last before dot next. And also this is if this is smaller than. Okay, so we fixed a few things. Let's run it again and see what happens. Okay, so we go to here. That's the part of the code we're interested in. Okay. So, okay, now before this iter is at this node here, and before points to it before points to it, perfect. Okay, so last before dot iter equals this last before dot next equals iter. Yep, that's already the case. Last before equals to iter. Okay, so before starts here and ends here. Perfect. Okay. Last before again. So now last before will be here. So before starts here and then it ends here. This is perfect. This is exactly what we want. Okay. So now we exit the while loop. We exit the while loop. And then we say there's no after, right? There's just before. So head equals to before. Head should now point to this guy over here. And then last before dot next equals to mid. Okay, this is kind of funky. So head points to here. And then last before points back, this one points back to the beginning, to mid, which is correct. Okay, so this is correct. This should do what we want it to. Okay, cool beans. Now, what else do we want to do? What else we want to do is that before we stitch them back together, we want to do a few things. Okay, we want to do a few things. We want to make things a little bit easier to visualize. I'm going to break a few arrows. So we don't actually need to do this normally. But I want to break a few arrows to make things a little bit easier to visualize. Okay. Let's just sanity check to make sure we're still doing the right thing. Okay, so we zoom to the end. We're still doing the right thing. Head equals to this. This goes to here. And then this all the way goes back to here. Okay, cool. So I remove a few arrows. I remove the arrow between this and this. Because I want to make it clear. Yeah, likewise I removed a few arrows on the way. Just to make it nicer. Okay, cool. Now what we want to do is we want to, before we stitch before and after together, we're gonna sort. Before we stitch them together, we're gonna sort before and sort after. And the way we're gonna do it is we're gonna call the same function sort lists on before after equals sort list on after. So this is a little bit tricky. Because don't forget, I still need my last before and last after. So we're gonna make this function return two things. We're gonna make this function return not just the before and after, but also last values. Okay. This would be mid. If there's no after, then if there's no before, then this will be mid. If there's no after, no before, it will be last after. Okay. Cool. Let's see what happens if we run this. It breaks. Something is bad. But that's fine. Let's start from the beginning and see what happens. Okay, so we get to here. Okay, so we have mid. Mid is this guy over here. We have these three things. I'm pretty sure this part should be fine. Okay, so we're gonna jump here. Okay. So now we are in our first level of sort list, and we can see from here. In the first level sort list, we are sorting this before, right? Before is 2, 1, 3. So now, so mid.next. So our new mid is 2. Our new mid is 2. Okay. So our new before is 1 and 3. Sorry, our new rest of list iter is 1 and 3. So let's see what happens next. Okay, I gotta remove these breakpoints. These breakpoints are kind of annoying. The way breakpoints work in Python tutor, not that intuitive. There should be either... So there's just next here. There should be a button that says next breakpoint, and another button that says next line. So right now, if there's at least one breakpoint, it just jumps to next breakpoint, which should not be the case. I should have the option to jump to just force the next line. I see there's somebody in chat. Hi Chien, how's it going? I don't know if you're passively listening or you are actually watching, you're following along. But let me know. And if you have ideas for how to solve this problem, feel free to jump in. This is going to be a collaborative exercise. I'm also going to try and figure out what's the best way I have to make sure I can see everybody's chat. Oh, no worries. Do you just get in? Okay. I'm going to give you a 1-minute explanation of what the problem is. Okay? You ready? 1 minute. Because I don't want to hold everything up. Oh my god, there's like a bunch of stuff here. Okay, I'm going to clear this. So the problem is we are given a linked list. A linked list looks like this. It's not like a regular list. A linked list has elements that point to the next element. Do you know what a linked list is, by the way? I think you do, right? Yeah, so the idea is we're given a linked list and we're supposed to write a sorting function for a linked list. So a linked list, basically, each circle here is a list node. It has a value, which is this number here, and it has a next pointer to the next list node. So this means the main difference between a linked list and a regular list is that it's really difficult. Okay, no. Perfect. So I'll do a better explanation. The main difference between a linked list and a regular list is that a linked list, this is the definition for a linked list. Each of these circles here is a list node. Excuse me. It's a list node. It contains a value. That's whatever payload it has. Here is number 4. And it contains this next pointer. So it points to the next circle. Oh, thank you. Damn. Oh no. Oh, drat. I just signed out of this. Oh my god. So I just signed up of my own accounts on my streaming software. Shucks. So I just signed up of okay. Alright, this sucks. Okay, give me a second. I gotta get my chat back. Okay, perfect. So I signed out of the window that allows me to see the chat. Streaming is so different from what I thought it would be. There's like 1,000 things on my screen right now. There's literally 1,000 things on my screen right now. I can barely see what I'm typing, even though they don't appear on the stream. Okay, so back to the linked list. So a linked list is a data structure where there's a value and there's a next pointer. And the idea is instead of allocating a contiguous block of memory, you can to store a list, you can now have a bunch of memory blobs in different places, and they just point to each other. And so this makes it easier to so first of all, it makes it easier to insert and delete things in the middle of the list. So regular lists, regular array, if you delete something in the middle, you have to move everything up. Everything has to go up. But linked list, if you want to, let's say, delete this guy, all you have to do is take this pointer and then point it at number 3. And then this guy goes away. So this 1 goes away. So linked list is good if you have to insert and delete things a lot. But the problem with linked lists, as we're slowly figuring out today, realizing today firsthand, is that linked list doesn't allow you to jump to the middle of the list. So if you want to say, want to get to this last thing here, this number 3, you just start from 4, go next to 2, and then 2 dot next to 1, and then 1 dot next to 3, and you have to keep going using this next value here, this next pointer here. Does that make sense? I hope it makes sense. Okay. Yeah, okay, pointing to the next circle, exactly. Yeah. So this is just a data structure. Linked lists used to be very, very popular a long time ago, like 20, 30 years ago. But today, people don't use them anymore. People just use lists. And we let the programming language library sort out whether it's an array or a linked list. Okay. So, based on that, what we've been doing, you know what? Since you are the only viewer here, we can take a one more minute to explain what we're doing so far. So we've been trying to do, but not sure why I lost. Don't worry about it. So what we're trying to do is we're trying to write quicksort that works on a linked list. So normal quicksort works on an array, the one that you're familiar with, where you mark out blocks of the array as before and after. You do some swapping of indexes around. We're going to essentially, what I've been trying to do is essentially write quicksort, but on a linked list instead. So we've gotten up to here. So if you're familiar with quicksort, that's the mid. And then we start with mid, and we sort the rest of the list into before and after. So the idea is, again, you're familiar with quicksort, right? Okay, I'll just quickly say it. So the idea, for instance, if 4 is the sort of midpoint, the fulcrum we call it, we take everybody else and we say we put them either before or after 4. So 2, 1, and 3 are all before 4. So this is before, and this is after, and then we sort this, and then we combine these things together. So that's what we're doing. Okay, cool. So we're in the middle of doing this. My DSA is limited. Data structures and algorithms? Yes. That is fine. You know, a lot of my students have the same problems. They really struggle. Sorry, I have a bad cough for some reason. A lot of my students really struggle with data structures. I feel like more drawings help, I think. Okay, so what we've done so far is we have written one iteration on the loop. Okay, step 1 is we identify the mid. So in this case, we have 4, 2, and 4, 2, 1, and 3, right? We take the first one as a fulcrum. We call it the mid, and we say 4 is now in the middle. Everybody before 4 goes to the before, and everybody after 4 goes to after. And so what we've done here is, thank you for the go get well soon. I'm also a very visual person. So what we've done here is we say while iter not equals to none. So we're traveling down these blue arrows one by one. We look at the value. If it's before, we look at the value. If it's before, then we put it into before. If it's after, we put it in after. My cough is getting worse for some reason. I might have to stop streaming halfway. But now it's fine. I think it's fine. We'll see how things go in a bit. But we might have to stop today's stream halfway without completing the problem. Okay, so what we've done is we did the before and after, and that worked. Okay. But when we introduce this sorting, when we tried to sort before and after, that didn't work. So we're trying to debug what's going on. So we're in the middle of debugging. So we've just done this successfully. This 4, we put 2, 1, and 3 on the left hand side. And now we're doing the same algorithm to the before list. We're going to take 2, 1, and 3, we're going to sort them. And we're going to do it in the same way. Which means we're going to say 2 is now the new fulcrum. We want 1 to be before and 3 to be after. And after we're done, we can take this whole thing and pass it back to the sort of level in blue. And let that stitch us together. So something is happening here that I think it's not right. So iter dot none. So let's rehash flashback to where we were. So mid is 2. So the new mid is 2. This is correct. By the way, Chien, does that help? I don't know whether it's easy to catch up or not. It's halfway through. But you let me know. You can always go back and watch the VOD. So mid equals to this. Head also equals to this. The before and after are empty, so we're going to go to this. So iter equals to 1. Since 1 is smaller than 2, so now fulcrum is that we're 1. We want 1 to go into the left hand side. We want 1 to be before. Let's see whether that happens. Okay. So 1 indeed goes to before. O iter equals next. Okay, iter. And then we remove. We use this O iter to cut off. Now 1's next is none. What's the lines and charts on the right hand? Does it automatically generate? Yes, it does. This is the website Python Tutor. You also don't know Python. Oh, interesting. Python is actually a really good language to learn. It's fast becoming my favorite language because I teach. So Python is really easy to teach. So yes, it does automatically generate. Go to this place called pythontutor.com. You can see here pythontutor.com. I'm not affiliated with them in any way, but I'm a fan. Big Brother Ruby. That's debatable. Some people would have a lot to say about that statement. Big Brother of Ruby. I think the Ruby people will be unhappy with that. Fun fact, I actually worked with Ruby a lot when I was working on my PhD dissertation. Because Ruby is really good. Ruby is a very interesting language because you can open up Ruby and change everything it does. You can turn Ruby into a new language completely with new syntax and new everything else. So Ruby is a very reflective language. You can change the definition of keywords like while and if and even like classes. You can change how it works. Python is also very forgivable. Python is pretty good too. They are both very next generation. Very next generation. Okay. I am going to, let's see. Yeah. So because this problem has a lot of like visualization. So having this Python tutor helps a lot. You can also have this like debugger at the bottom. And the special thing about this debugger I like a lot is that it allows you to go backwards. Regular debuggers do not allow you to go backwards. This one does. So try it out if you're working on problems. Yeah. Okay. So iter.value smaller than mid value. Okay, this is correct. Wait, what is last after? Something is wrong here. So 1 is supposed to point to 3. Oh no, it's not supposed to. I see. Okay. So cool. This is correct. So before goes to 1. Mid goes to 2. And then after goes to 3. Okay? So this part is actually correct. So we got 2 in the middle. Before is 1. And then after is 3. So this is perfect. So now we get to the next part. And again, sorry, Chien, there's already a lot of code written before you got here. So it can be a little bit confusing. Sorry about that. And because I am a little bit unwell today, otherwise I will be happy to go back to the beginning and we can start from there. If it helps. But now that we have 1, 2, and 3, we have before and after done, we're gonna stitch them together. And this is the code that does that. We say head is now before. Head is now before. And then last before, the last thing in before, goes to mid. So head goes to before. The last before goes to mid. And then mid dot next equals after. So 2 goes to 3. And then last after next equals none. So 3 goes to none. None is like a now. It's like a nil in Python. None is like now. Okay, so this should work. That's very strange. Why doesn't it work then? Okay. Okay. So now you sort before and after. Sort before should just return now and now. Head and none. Oh, I see. So this is the problem. It's not head and none, it's head and head. Head and head. When this happens, this line of code happens, when there is only one item or 0 items in the list. So if head.next equals to none, that means there's only one item in the list. There is no arrow. There is no arrow. It's just one circle with no arrow. And this is if there's no circle at all. So in that case, I should return head head. Because if there's one circle, then the first and the last is the same circle. If there's no circle, then they're both none. I should return head head, which is none none. Okay, let's visualize execution here. Sort list before. Okay, so we got some traction here. It seems to be working. Okay, so sort list before before is 2 3. Oh, that's weird. Why doesn't it work? Okay. Oh, I get it. It's supposed to return head last. Okay, so this is one of the cool things about Python, which is you can return multiple you can return multiple things basically. Okay, so it looks like it's working now. Okay, so we've we're popped out of the first level iteration. Okay, and we can see now our list as it stands looks like this. We have head. Well, we have this 4 here, which I think is head. Yeah, 4, which is head. We have before. Okay, no, it's not as far as I thought it would be. Okay, so here, this is where we were just now. We have 2, 1, and 3. We have 1, 2, and 3. So we sorted the before list. So the before looks like this. The before looks like 1, 2, and 3. And if we do the next, before is none, no. After is none, true. Then head equals to before. You see, head now goes to before. Last before is this 3 over here. It will last before will connect to mid, which is 4. And then mid will connect to nothing. Okay? And our final answer is head goes to here, goes to here, goes to here, goes to here. So this is correct. So this works. So we just take this and copy it back to LeetCode. This is going to be a separate function. We're going to call it a helper. And the reason for that is because our helper actually returns 2 things instead of 1. Helper self head. So we have to recursively call helper here. Head last equals helper head return head. I think this should work. Okay, let's run it. The lines are actually kind of confusing. Yes, they are. Yeah, they are kind of confusing. I wish they had better visualization. Self.helper. Yeah. Okay. So we can see that this works for the small trial test cases. So we basically wrote quicksort. They need a front-end developer. So I will say something though, in defense. I actually tried writing something like this before. Like I tried writing something like this before, where you have like these boxes, and you auto-generate the boxes, their positions, and you generate the lines that connect these things together. It turns out that this is a pretty hard problem. Like the layout is tricky. Yeah, they do need a front-end developer. The layout is actually quite tricky. Like making sure that these boxes are in the right place, that's tricky. So I think one thing that I will sort of suggest to them, if I could, is instead of trying to make the layout really nice, just allow us to move these boxes. Like these boxes over here, if I can click and drag them around, then it makes it a little bit easier, because if I want to find out which lines connect to boxes, I just wiggle it around. Yeah. So if we want to solve the problem of actually getting the lines to not be jumbled up, that's really, really difficult. Like this box here, it's got lines coming from these 2 places. This guy has lines coming from up there, down. This guy has up here, down here. So a bunch of different lines. So if we can make these things boxes draggable, and I can like just jiggle them a little bit, I'll find out which lines they're from. Or if I click on the box and it shows me where the arrows are coming from, that helps too. Different colors from lines, yeah, I agree. Like if you click on one of these boxes, it should turn, darker, and then the lines also, its lines get highlighted. Yeah, value 2 is green. Yeah, exactly. Yeah, so each of these boxes have a slightly different color. But even that is hard, because when you have a bunch of boxes, then it also gets confusing. And they use different color lines for like different levels of the core stack. So yeah, you know what? Is there a suggestion box? There's no suggestion box. Yeah, maybe get AI help. That's not what we want. But if there's a suggestion box, I can, we could enter a suggestion and tell them. I think having making different values, different colors is a good idea. Okay, so this works for our 3 simple test cases. I'm pretty sure it won't work for the big one. And the reason why is because there's a recursion here. So I'm always very suspicious of recursion. When we scale up, recursion, I think in many languages, okay, exactly. This is what happens. This is what happens. You see what's happening here? So, yeah. This is what's happening. Because we have a very large number, our recursion core stack becomes very deep. And that breaks large test cases like this. So let's do a thing. Let's come back to this problem the next time around, and we'll try to fix it. So we reach a good stopping point where we solve the simple cases. And as usual, the first one is throw away, remember guys? So 25 out of 30 test cases, not too bad. Change the code inspection. Oh, interesting. You can change the color on your own in the browser. Yes, you can. You can do that. But the thing is, then you have to click on each of the arrows and change them manually. So you can do that. You know what? I'm super curious. How hard is it to like click on the arrow? Okay, this is the arrow, right? What's the color? Fill style none. Stroke. Oh, this. Can I change this into something? Did something change? Huh. I don't know. Well, turning this into the front end. Okay, we're gonna end up rewriting the whole thing on our own. Actually, I looked into a bunch of IDEs to see which one is the best. I couldn't find anything better than Python Tutor. In fact, I couldn't find anything that is visual like Python Tutor. This is the only one I find. Look at the styles. Yeah. I'm not a front-end developer. That is true. Style fill none. Can I play with this? 10. What happens? Nice! So it becomes fat. But when I move it, it changes. When I move it, it changes because there's some JavaScript that changes the color. You'll change the style back again. It works. Yes, it does work. Okay, cool. So I think that's going to be it. Xian, do you have any last words or shout outs for the channel since you're here? You're actually my second viewer, FYI. So I had someone turn up the other day, but they weren't as chatty as you were. So I really appreciate this. Last word, well, not that kind of last words. Any shout outs to fans of this channel, which is like 15 people. That's not a lot of people. tell us beforehand. The question? Yeah, actually the question is posted beforehand. So I select the question on the what level of difficulty. Oh, So I think it does appear. It does appear. Would it be helpful? Is this too difficult? Do you think? Should I lower the level of difficulty? By the way, let me quickly do an outro here. And so in case I want to cut out the rest of the video. So we have reached a great stopping point. I want to thank everybody for sticking around. We will continue working on this problem next time around, solve the last few edge cases. So see you guys next time. Ciao. Okay, so that's the outro. Let's see, so we can continue talking. Yes, for me, first of all, my DSA is limited. Yeah. Okay, so I started by doing easy problems. The easy problems seem like super easy, so I upgraded to medium problems. And here we are. So maybe next time after this problem I'll do something easier. Does that make sense? I feel like that makes sense, right? Yeah, the other thing about problems is that on stream problems are a little bit, it's hard to follow things on stream. Look at my phone. Okay, let me end my stream first. Hold on, let me end my stream first.